All right, so last week we kind of ended on this note where we took, let's hide this one, where we had these curves that we started to swirl around and give it this kind of fluid motion. And then we used this graph mapping to give it some height. Um, so what I like about with this graph mapper is that you can have a lot of control over creating interesting elevation change. So if I go to graph type, you can see it's this Perlin one. There's obviously all the different types, but this one gives you kind of this interesting profile for how these curves start to move up. So you can start to see like here, this start of this area is over here, and then as it moves across, that's where it dips down, and then it goes back up, and then has this interesting thing. So it creates a pretty interesting vertical elevation change. But we kind of ran into some hiccups by just lofting these surfaces together. I think that's usually when you see a series of curves that you immediately want to just assume that you can loft them all together, but it caused some issues. So let's go back to kind of the fundamentals of how we talked about creating surfaces. Is there an easier way to create surfaces other than lofting curves?
You just created from that contours instead of multiple.
Say what again?
Created surface from contour.
You could, I guess. I've never tried that. I mean, that's essentially the same thing. Are you thinking like using a patch or something?
Great. Exactly.
Drape. I'm never a fan of the drape tool. I don't know why.
Does it lose too much resolution for you?
Yeah.
But it's quick and easy, and it's a usable surface.
Yeah, suppose. What did we, so you can use curves to create a surface, right? Is there another type of um, geometry component that can create surfaces? Huh?
Points.
Points, right? So we can start to kind of work backwards a little bit by creating a series of points along these curves. So if I go to my curve component, go to division, and divide these curves to create basically a point cloud along that. So I can choose the number of points. It's not going to make a huge difference, but we'll play around with it. So 10, less than 20, less than 30. So let's start off. So we have 20 points going. Oops. So now I'm just left with the points here. So from there, we can go to our surface component, freeform, and then do surface from points. It's asking for the first thing to input a grid of points. That's the points from here. The first thing you want to do, you can see that this dashed line means the points are separated in their own sets or branches. Go ahead and just right click and flatten it so it's just treating it as a large group of points. So you can see it's all grouped into 861 values versus this one has the different number of points in each set. So it's still not doing anything. It still needs this U count. So the U count is essentially the number of items or data in a certain direction. For whatever reason, I know we draw in Rhino like on the X, Y, and Z coordinates, but when it comes to the Grasshopper components, it's kind of like a computer program, so it uses U and V directions. So U is essentially your x-axis, and then if you see a V, that's usually your y-axis. So it's asking for a U count. So how many items are going in the U direction? How do we figure that out? I'll give you a hint. It's not this count that we have for 20. I turn this off. So it's looking for a number of objects that are going in the X or the U direction. What might that be? It's literally right there in front of you. The contour of the curves. So if I look here and I hover over this G, it says that there's 41 locally defined values. So that's basically, those are the 41 values going in the U direction, or essentially your U count. So you have to find a way to convert essentially geometry into a number, which sounds kind of weird. But if you go over to the sets, you can use the list tab and choose list length. So basically this is just going to take however number of items. So in this case, you have 41 polyline curves, and it just spits out 41. It just says however many objects are in that set, it just gives you a numeric value. Does that make sense? So this becomes your U count. So now when I drag this in here, because it's asking for how many objects are going in that direction, and I drag that in, and now I have this nice fluid solid surface. So that's why I'm always a fan of using the surface from points component, because you can take really accurate readings for your surface. And the reason we want to do like use this component instead of just saying like inputting a rigid 41 number in there is because if I go back over here, you'll see this is actually what's controlling it. I've taken a curve and I've divided it into 40 segments or 41 points, which are kind of wrapping around this. And that's what's creating those 41 curves. So if I change the number of points that are wrapping around this, creating these lines. So now it's becoming just more detailed. I see I have 75, and now this component is spitting out 76. So that way it just all kind of responds to each other. Let's drop this back down to 40. I'll turn this. Oops, I keep hitting that. Does that logic make sense? Is anyone completely lost on it? Okay, so in this, like I said, like what's cool is with this profile, you start to see how all those different curves are going up and down in these interesting directions. Looks kind of cool. There's this like mini canyon going through here, and then there's this larger kind of drainage area, and then there's also like another miniature one over there. Obviously, I can change even the quality of this profile with this one, which is nice. Right now, it's kind of very jagged. If I take this one over here and start to drop it down, it starts to smooth it out. So now you can see it's a little less, there's a lot less ridges in it versus so you can almost make it very subtle versus when you start to really kind of jump it up, it adds more of those ridges to it, which is pretty cool. So now it almost looks like you've taken a sheet of cloth or something and started to kind of mold it with your hands by kind of creating all these seams or ridges with it. That's why I'm an advocate of using these kind of vector forces. That's my plug for it. Okay, so you have your surface now. what is the assignment asking for? Sections and contours. That's really what we'll focus on today, of ways of kind of showing that information. So the contours are pretty simple. However, you do need to have some volume to this. You can't just do your section cuts from a single plane. So first thing we want to do is create this as an actual closed B-rep or a three-dimensional solid object. So the first thing I'm going to do is type project. So project an object onto a plane. So I'll drag this into here. So now I just have a flat projection of that same surface. Projects it onto a plane. I want to have this plane much lower because what is the Z value limits? 60. So let's go to vector, plane, XY, and then I can construct a point and just change its Z value. So I'll do -50 less than 0. So this is going to control how far that projects down. So let's have it go down a significant amount. Okay. So from here, we can simply take the curve of these surfaces. So I'll do parameter, use the curve to do it for that one, as well as this one. So I'll just have those two closed curves. And now I can just use the loft command or the loft component. Oh, I keep hitting disabled. And now with the projected surface, this top one, and this lofted surface, I can join it all together. So let's go to surface, B-rep join, drag that into there, drag this and this. Now we can see that it's just producing a closed B-rep. So closed B-rep, now it's just a nice solid volume. So let's create our contours for it now. I'll say that when you're doing the actual contours for this, you don't have to do it for your entire volume. You might when you start to get into the fabrication phase where you need to start stacking this, but for graphic purposes, you're just going to want to actually contour your surface itself, not the rest of that. So that's right there. So let's type contour, use this first one. And what are the intervals that we need to use? Nope. What intervals of contour lines do you need? No, 1 foot, and also that's highlighting the 10 foot. So let's do 1. So here's all our 1 foot contours. Let's also do a 10 foot one. So I'll just copy and paste this, do 10. But now we can see where those 10 foot contours are. This one really only has that one, so I could always exaggerate it as well. But, so there's your top view contours. Doing the section ones are pretty easy as well. We'll just do it for this entire surface. So let's go ahead and again do the contour component. I guess I can just copy this one. We'll do it for this B rep, so this entire volume. And now we just need to change the direction. So you have this N input, so direction, instead of it going in the Z direction, we need to go in which directions? What was that, Green? I heard you. X and Y. So again, I can go vector, X. I can just drag that into there. And there's my X contour lines. The sides for this one are a little jagged, so you might need to trim it up or clean it up if you need to. And you can also then use your Y. So there's your Y contours. And what's nice is when you create this volume and that it actually closes it off as well. So again, there's kind of some weird things going on. But
So how would you trim it if it's a grasshopper?
trim what?
Trim like the edges.
So what you could do is, that's a good one, Aaron. Let's go over to this one. So if we want to trim this, let's say, like, just for the sake of purposes of like getting rid of this kind of blob and this, and let's just focus on having a clean piece. We can just draw a rectangle in Rhino, because we don't want to like affect like all our analysis of this. So we don't want to actually physically trim it and do all that. We can just do that all in Grasshopper. So I'm going to use that curve. I'm going to reference it in here now. So there's that curve. Essentially, you'd probably want to do that before you do the projection over here. So let's go ahead and kind of shift all this around. So before you start to loft it, you want to really just trim that original surface before you begin to loft it and all that. So I can take my square, or that square curve I just used, do project, and use the project the curve onto a B rep. So it's asking for the curve, so that's this one. The surface is this B rep. And so now I have, let's hide this, hide these. So now you can see that rectangle is nice and flush with your surface. And so now you can trim that away. So I'm going to do surface split in this case. So surface, base surface to split, that's this one. The curve to split it. Let's go ahead and get rid of this. So it's really only split it. It hasn't trimmed it away yet. When you look at here, you'll see, when you hover over, you see that there's two trimmed surfaces. You have to go to your sets, list item to essentially pull out the one that you want to use. So I keep doing that. So I can see that the first item is actually that leftover. So that index is 0. If I do 1, which is just the next item, now I have my trimmed surface. And now I can essentially do the same thing where I project it down, and also join it. So you're just going to replace all that. So now you're going to join this surface with this projected surface of that. Also, grab this curve for it and this curve. And now you have your new solid. So use the surface split component to do that.
So do you think we should make these landforms a little?
Yeah, you might want to go a little bit beyond those extents. That's usually just a good safe rule of thumb, whether it's for this. I do it also whenever I'm doing renderings and stuff because I don't know if I have to like shift my drawing over or not. It's kind of just a nice safe rule of thumb whenever you're doing stuff that has some limits. So kind of lose some of the details of it, but it's still interesting. So this now, all these contours should look pretty clean now. I don't know what happened to that bottom. Oh, it's because I need this one as well. There we go. So there you go. Luckily, because you only have to do like 10 section cuts, it shouldn't be that difficult to just manually kind of pull them out for Illustrator to lay them out. But if you have like, I'll show you a really kind of cool trick. What happens if you, kind of like how the second years did in their studio where they have like hundreds of section cuts and then they have to figure out how to order them and for the laser cutter and keep them all kind of together. Here's a cool little trick. So let's say we do have 100 cuts through this. Oops, it isn't. Oh, it's distance, it's not number. Oops, wrong one. So let's do, so let's say we're doing these 1 unit increment cuts of that. And we need to prepare this for the laser cutter. So what you can do, which is pretty easy, is so we can look at here. Let's go ahead and flatten this. I don't know why that's such a pain, but we can see that there's 71 cuts. Does anybody want to manually shift these all over and organize them? I'd hope not. So we can create a grid and start to lay these out. We can even start to scale them, which is nice. So I think, let's see, this is about maybe around 75 feet by 75 feet now, give or take, probably closer to 70. We can shrink it all down and also have them all nicely laid out in a grid. So first thing I'm going to do is find the center point of each one of these curves. So I'm going to do area. This is really just going to create a series of points. For whatever reason, it doesn't like over there. Something odd, but whatever, it doesn't really matter. So you have all the center points of these curves. Okay. And we're going to use these points to help us kind of figure out where to lay everything else out. So I'm going to create a grid. And let's say we want to shrink these down to be, I don't know, 2 feet. instead of 70 something. So let's make the cell size 2. Oops. Oh man, I'm off today. So 2 is the cell size. So that's just how big these squares are. And we need to have 71 of them. So 5 by 5. So let's do something like, I don't know what's a good square of that. Let's just do something like 80. So we'll just do, no, not 80. A good square factor. Yeah, there you go. Thank you, Aaron. So 9 by 9. So now we can see that we have 81 cells. I'll go ahead and flatten these as well. And I'm going to do the same thing where I want to find the center point. So area. So there's point. So we're basically going to take the center of all these profile curves and match them to be the center in all of these, but laying flat. So, as in addition to scaling it. So the first thing we have to do is figure out the actual plane that these are sitting on. So what is this plane? Like if these are vertical cuts? Nope, there's 2 axes that you need. A good trick, because it should be set already in your Rhino workspace. So if you go down to this global icon right here, you can see when I'm looking at it straight on, I see that it's the XZ plane. So I'll use plane, XZ, and so that these are the contours. These are on the XZ plane. I'll drag it so now I can see that they're all oriented. And essentially we want to orientate this plane to be along with like this plane. So what we can do now is, let's go ahead and scale them. So I'm going to take our contours, scale them from these center points so that they're about, let's try 1/10 of their size. So now I see they're all starting to get a little bit smaller. Probably need to be a little bit smaller than that. So let's do 0.05. So now they're smaller. Nothing else has really changed. So we have this plane, that plane. Now if I go to the transform here, go to this tab and do orient. So it's asking for geometry to orient the starting initial plane. So that's this XZ plane. And then these don't really need to say it's XY, it's just default to that. And now, let's get rid of this. I don't know why they're, so maybe they need to be a little smaller. Or the cell could be bigger. So there you go. Now you have all your section cuts nice and laid out. Exactly. So we can just simply do, if we go to display, do a 3D text tab, So location, that's here. And this just does it in sequential order, so you don't have to worry about organizing it like that. So text, so if we have contours, we know again we have, in this case, 71. So I'm going to use that same thing where I'm going to find the length. So list length, 71. And again, we need to create a series of numbers. So if I go to sequence, series, we can start the number at whatever you want. In this case, I'm just going to start it at 1. They'll start at 1, go in increments of 1, and do it up until it gets to 71. So now it goes 1, 2, 3, and so forth, all the way to 71. Drag that into the text. I can change where it's justified, so I'll just do like middle center. Change the size. So what was it up before? 1, so like 0.15. And there you go. So now when you start to cut them out, you don't have to worry about losing track of them. So that's kind of a cool little fabrication setup. Or when you, like if you wanted to do something where you show like 100 profile cuts in a drawing, you could do the same approach, just so you don't have to manually pull each one across. So I mean, it's not that difficult of an operation, but it saves time, I suppose.
One more question.
Uh-huh.
If you, like, say you wanted to put like a circle or something else on that, how would you do that?
Put a circle?
Like instead of a number, if you just wanted to.
Sure. So it's the same thing. You have the center point. So all these points. So are you saying like if you want to have like a dowel to kind of connect them all? Sure, that's easy. Let's just go to our curve, primitive, circle. Change the radius for this as well. There you go. So you can change it.
You just right click the tag and move it to the left and the right.
Yep. So I can just change its justification or move it.
I'm gonna save you a lot of time.
Probably. Yeah, it's a shame we don't have like the CNC router too, because like who's the team that did the straws? So you can set up the CNC router to not actually cut out, but just drill holes. And so you could actually, instead of doing like a very kind of boring uniform grid of points, you could actually do like this, an interesting kind of parametric grid, and the router will just do it all.
And we still have to put the straw in.
You still have to put the straws. But we did a project for that, like that in grad school. We took maybe like a 4x8 sheet of giant insulation foam and drilled holes based off like a point density cloud of like this person's like half their face. So it had like really a lot of points located like in the darker areas of the profile picture, and then it kind of spread out when it got into those lighter tones. And then we had to like slap on a layer of plaster on it, so then we had to like go back through it and repoke those holes. But yeah, one day we'll have that CNC router, and you can do, imagine like being able to actually CNC route this. That would be pretty awesome, instead of just stacking it chipboard. Probably. You know, it should be ready for you guys in the fall. Yeah.
Well, aren't those examples of CNC routed tiles in the hallway?
Mm-hmm.
Where'd they do those?
When we had a working CNC
Oh.
router. Now it's just a dust collector.
Yeah.
Okay, so And yeah, like if you want, you can even make it more advanced. So you have a series of dowels or holes that are cut in this. You could just do, you could take that center point and also move it in the X direction. And also probably like the inverse of that. So if I do vector, reverse, I guess I gotta do graft it, and then I could do that also. So now I have like 3 dowels that I could use, so it's actually nice and clean. So yeah, there you go. Okay, so where are we at? 150. Okay. Any questions from you guys so far? All right. I'm gonna go ahead and just pause this or stop it right now.